Hello everyone, this is your tutor AB and today we're going to be looking at an IB physics problem HL from the November 2019 examination sessions. So let's take a look. This is a 1 mark from the paper 1. The gravitational potential is V at a distance r above the surface of a spherical planet of radius r and uniform density. What is the gravitational potential at a distance 2r above the surface of the planet? Well, before we work this question out, let's just visualize what they're asking here. We have a planet of radius r. So this is r. And in our first scenario, we are at a distance r from the surface. So there. So from the center of the planet, we are 2r away. And the second scenario, we are at a distance 2r from the surface of the planet, so we're at a distance 3r from the surface of the planet, and this is important and you'll see in a second. So what's the formula for gravitational potential? This is in your data booklet, but I highly recommend that you memorize this. V is equal to gm over r. This is gravitational potential. Well, at this first position right here, let's label this 1. The gravitational potential V is equal to gm over 2r, right? Let's call that V1. And at the second position, V2, the gravitational potential will be gm over 3r. Notice we always take the distance from the center of the planet, not the surface, the center. So we add up the r's together and we get 3r and 2r respectively. So what are they asking us? They're asking us for the gravitational potential at a distance 2r from the surface of the planet. So they're asking us, what is the gravitational potential V2? So there's a neat technique towards solving these type of questions, and this is just division. You can create a fraction where you divide the two expressions you've created and put the one you're solving for on top. So in this case, I'm solving for V2, so V2 goes on top. V1's on the bottom, and on the other side we just write the equivalent expression. So we have gm over 3r divided by gm over 2r. Now using basic fraction manipulation, we get v2 over v1 is equal to gm over 3r multiplied into 2r over gm, and all I did was take the reciprocal because it's division. Gm cancel, r cancel, so I'm left with v2 is equal to 2 over 3 v1, and v1 of course I'm taking as the original position at this first position, and v2 is the second position. That's what I've solved for. So I'm writing v2 in terms of v1, and that's our answer. So D.